In Learning Target 4, we'll talk about solving quadratic equations with the quadratic formula, and we'll discuss the discriminant. Up to this point, we've talked about solving quadratic equations using factoring, and we've talked about some strategies about how to do that. And it's about time we talked about one strategy that will work for all quadratic equations, and that is the quadratic formula. Right here is our quadratic formula. If ax squared plus bx plus c is equal to 0, and we know that a is not equal to 0 because if a were equal to 0, we'd no longer have a quadratic, then we can use this formula, the quadratic formula, to solve any quadratic equation. So I want you to go ahead and memorize this. Write it out a few times, do whatever you need to make sure you have it memorized. Here's an example. If you'll notice, we've identified our different terms here. We can see that our a term is 2 right here. We've got a 2 for our a term, and our b term is 3. And our c term is -5. And what we're going to do is just plug them into that formula so that we have a negative b. Since 3 is positive, we'll make it actually negative, plus or minus the square root of b squared minus 4 times a, which was 2, times c, which was -5. And then we're going to put that all over 2 times a. And that will give us the solution to our quadratic equation, or the roots to our quadratic equation. Here's our first equation. What are the solutions of x squared minus 8 equal to 2x? Now take a look at this equation, and what do you notice? One of the first things you should notice is that it is not in standard form. If we're going to use the quadratic formula, we need our equation to be in standard form. So let's go ahead and put it in standard form. We'll have x squared minus 8. And then we're going to take this negative 2x and we're going to bring that over here. So that will leave us with x squared minus 8 minus 2x. Now, is it in standard form? No, it's still not in standard form. So we're going to go ahead and put it in descending order of the exponents. And now we have it in standard form, and we can use our quadratic equation. And I hope you have that memorized. It is. So let's plug in our different values. So for negative b, we're going to take the negative, the opposite, of -2, which is going to be +2. So we'll have 2 plus or minus the square root of b squared, and of course, -2 squared is 4, b squared minus 4 times a, which is, in this case, our coefficient is 1, and -8. We're going to put all that over 2 times a, right? So 2 times a, which is 1. And if you want, you can go ahead and pause this and punch that into your calculator. When I do, I get that this is 2 plus or minus the square root of 36. When you multiply all those together and subtract, or in this case, it becomes a negative and you add it, you'll get 36 over 2. And of course, we know the square root of 36 is 6. So it's 2 plus or minus 6 over 2. Now this is important. At this point, we need to remember that we have two different solutions. We have 2 plus 6 over 2, or we have 2 minus 6 over 2. Remember that our parabolas intersect the y-axis at two different points, right? Unless they only have one solution, in which case they only do it at one point, or if they have no solutions, they won't intersect at all. But most of our parabolas are going to have two intersection points. So at this point, we'll just solve. 2 plus 6 is 8, and 8 divided by 2 is just 4, or 2 minus 6 divided by 2 is -4 over 2, and that gives us -2. So our answers are 4 or -2 for this parabola. That is the points at which our parabola intersect the x-axis, which are the solutions to our quadratic equation. Now that last one was pretty easy, giving us whole numbers and all. Let's try one that's a little bit more complicated. Let's use our same formula, then we'll just plug in our values. So -b, since 12 is positive, we're going to use -12 plus or minus the square root of b squared, which is 12, that's 144, got that memorized, minus 4 times a, which is 5, times c, which is -2, and we'll put that all over 2 times a, which is 5. Now, when you punch that all into your calculator, you're going to get negative 12 plus or minus the square root of 184 all over 10. Now, when we look at our square root here, we can see that this is not going to be a square root that is a perfect square. In some problem, it's going to be fine just to leave it here at negative 12 plus or minus the square root of 184 over 10. That's fine. In other problems, we'll be required to write this as a decimal answer. So let's go ahead and punch the rest of it in our calculator. Our two possibilities are negative 12 plus the square root of 184 over 10, and the other alternative is negative 12 minus the square root of 184 over 10. Either one of these will be correct, will be a solution to our parabola where it intersects the x-axis. When we punch that into our calculator, we find that negative 12 plus the square root of 184 over 10 gives us 0.1564, etc. We're going to round that to the nearest hundredth, so 0.16 or negative 2.56. And those are the two solutions to our quadratic equation. Remember that in your practice, you may find your answer in any one of these two formats. You may find it looking a little bit like this, or you may find it looking a little bit like this. Just be ready for both of them.